Today we are continuing what we started yesterday. We're doing the application of vector valued functions. This is very much like derivatives and second derivatives, velocity and acceleration for what we did with straight line motion, but now we're doing motion on a curve instead of on a straight line. So motion along curved paths as opposed to straight line motion. That's what's different. Okay? So everything is the same as far as the R of t's go. R of t equals x of ti, y of tj. It's going to have those t's as well as i's and j's in there. So if you happen to not be here yesterday, it's going to be a little bit weird for a few minutes, and then hopefully you'll catch on and see where we are. So what's important today is in the box. We have x of t and y of t in front of the i's and j's. The way you find velocity is you take the derivative of the x part and then the derivative of the y part. To find acceleration, you take the second derivative of the x part and the second derivative of the y part. And to find speed, it's the absolute value of velocity, which is the absolute value of the x's velocity squared and the y's velocity squared. Okay? So we're going to work through some problems, and we're going to put these into use. So take a look at number one. A particle moves along a planar curve described by r of t equals 3 sine of t over 2i, 3 cosine of t over 2j. It says generate a rectangular equation. A rectangular equation is one with x's and y's only. That describes the particle's motion. So we're going to basically see, without putting this in the calculator, what it's going to look like. And it's actually going to look like something you recognize. Okay? So what we do is we change it first to parametric form. We did this yesterday. What is the x equation that's embedded in this r equation? Which part of it is the x? The one with the I or the one with the j? The I. So it's 3 sine of t over 2. And then the y component is 3 cosine of t over 2. Okay? Now, that bothered some people in first period, and maybe bothering some of you as well, because isn't usually x the cosine and y the sine? Mm-hmm. You can't always assume that's going to be the case. You've got to look for the i's and the j's. Whatever's with I is x. Whatever's with j is y. It always works that way. That is a guaranteed it's going to be that way. Yes, ma'am?
I can't see what's written after sine.
T over 2. I messed up my t, and I kind of chopped it off with the fraction bar. All right. Now what we want to do is get rid of the t and put the x's and y's together. We did this a few days ago. It's been a while. Does anybody remember how we did it? Set them equal to each other? Kind of, yes. But what we did is we took one equation and set it equal to t, solve for t, and then plug it into the other equation. Okay? If they're equally difficult, start with x. Because then, when you plug it into the other, it's going to be y equals something, and that's what I want. Okay? So let's take the x equation, and I want to solve it for t. What do I do first? Divide both sides by 3. So x over 3 equals sine of t over 2. So how do I get the sine off of the t over 2? Inverse sine. So sine inverse of x over 3 equals t over 2. Now, I can multiply both sides by 2, but I'm not going to. And the reason why is because the other side is already a t over 2. So if I multiply both sides by 2, I'm going to have to turn right back around and divide both sides by 2. More work than I want to do. Since this says t over 2 and that says t over 2, I'm just going to plug it in for t over 2. Does that make sense? Mm-hmm. Okay. So now we come over here, and in place of t over 2, we put the sine inverse. So we have 3 cosine sine inverse of x over 3. How in the world do you do that? Okay.
Oh, well, you could replace the sine and cosine with x and y.
Not exactly. Not exactly. Okay? When you have a trig function and an inverse trig function, here is the easiest way I found to do it. Take what's in the parentheses and set it equal to theta. Okay? So I'm going to come up here in the rafters, and I'm going to write theta equals sine inverse of x over 3. I want to put this back into something that's a little more recognizable. So if I wanted to get rid of the sine inverse, I move it over, and I get sine of theta equals x over 3. I can draw that, and that's what I want to do. So I'm going to come down here, and I'm going to draw that in quadrant 1, putting the theta at the origin. Okay, the sine of theta is x over 3. In terms of SOHCAHTOA, what is the x and what is the 3? Opposite over hypotenuse. So the opposite is x. Now that's kind of weird, but it's right. And the hypotenuse is 3. Can you find the third side? Yes? Okay, let's do it quickly in our heads. Are we going to add the two sides or subtract them? Subtract them. Okay, so it's the square root of 9 minus x squared. Do you agree with that? Okay. Now remember, the sine inverse parentheses was changed to theta. So the question is saying, what is 3 times the cosine of theta? Can you tell me the cosine of theta off my picture? What two things comprise the cosine fraction? So it's going to be y equals 3 times what over what? Square root part, square root of 9 minus x squared over 3. Okay, can I clean that up? Oh yeah. 3's cancel out and I get y equals the square root of 9 minus x squared. What is that? Not really sure? Okay, let's take it and let's kind of clean it, rearrange it. Let's tweak it a little bit. See if we can turn it into something we recognize, because I told you it was going to be something you recognize. How about we take the square root off? What do I need to do?
Square both sides.
Square both sides. So y squared equals, yeah, some of you are already jumping ahead, 9 minus x squared. So move the x squared over and I get x squared plus y squared equals 9. And there it is. And that is a what?
Circle.
That's a circle. Very good. So that equation up there is a circle, a vector valued circle. All right? Not something we're used to seeing, but that is what it is. We just know it's a circle. Okay? Look at part B. Find the velocity vector, the acceleration vector, and the speed. And in this case, it asks you to interpret the speed because it's going to do something unusual. So what we do is write v of t equals. Now, according to our box of knowledge, it says v of t is the derivative of the x term and the derivative of the y term. So what is the derivative of 3 sine t over 2?
So what, 3 over 2 sine t over 2?
3 over 2, not sine anymore,
Oh, cosine.
cosine of t over 2. Now tell me where that over 2 on the 3 came from.
The derivative of t over 2.
The derivative of the inner, exactly. The derivative of the t over 2 is 1/2. So I took that derivative and threw it in the front. Does that make sense? Okay, don't forget the I. This is in terms of i's and j's. Plus, what about 3 cosine of t over 2? Is it going to be negative?
Yeah.
Yes. Negative 3 over 2 sine t over 2j. Are we good with that? Okay. That is the velocity vector. It has i's and j's in it. Okay. Now we need to do the acceleration vector. So a of t equals. So what do you think I'm going to do with velocity to get acceleration? Take the derivative again, just like we know how to do. So what is it going to be? 3 over 4, but it is negative 3 over 4 sine of t over 2i minus 3 over 4 cosine t over 2j. Yes, sir.
Be plus 3/4 cosine because like the other one was already negative.
The derivative of negative sine
Is negative.
is negative cosine, and that's why I put minus. Now, you could put plus and negative if you wanted to, either way. Okay? Have I found a vector for acceleration? Is that the answer for the acceleration vector?
No.
Is that a vector?
Yeah, it is.
Yeah, it is. It's got I's and J's on it, doesn't it?
It's not.
It's ugly, but I can't do anything else to it. That is the acceleration vector. That's it. That's what I want. Okay? Now they want the speed. Now come up here and look. Speed is the double absolute value of v of t, or the magnitude of v of t is a better way to say it. Big square root. Now notice what it says inside. X prime of t squared. Where did we do x prime? On velocity or acceleration? Velocity. So we're going to take 3/2 cosine t over 2 and square it. Oops, there's my other parentheses. Plus, we're going to square the y component. Negative 3/2 sine of t over 2 squared. Usually when stuff is multiplied, everything gets the power, okay? Is the 3/2 multiplied to the cosine? Yes. Is the cosine multiplied to the t over 2?
No.
No, it's embedded. The t over 2 is inside of it, so the t over 2 does not get squared, okay? So the way we write this, I'm going to move over a little bit. What is 3/2 squared?
9/4.
9/4 cosine squared t over 2 plus, you tell me, what's the second term? 9/4 again, sine, just plain sine? Squared of t over 2. Okay, that looks good, but that's not done. Yes, ma'am?
How did? Oh wait. Oh, never mind.
You figured it out? Okay. So this can clean up. You may not see it yet, but as soon as I do one step, you're going to go, oh, okay. What can I do? Take out the 9/4. Watch what happens when I do. 9/4 factored out leaves what? It leaves cosine squared of t over 2 plus sine squared of t over 2. And some of you already jumped ahead,
It equals.
and that equals 1, doesn't it?
Yes.
So I can get rid of that mess. So what is my answer? The square root of 9/4, which is what? 3/2. Okay? Speed usually comes out with t's in it. That's because depending on what t is, the speed can change. But in this instance, there are no t's. So what does that mean about the speed? It is constant. And that is the interpretation. The speed is constant. It's not always constant, but it is in this case. That's the interpretation. All right? Questions on that? Anybody? Okay, let's go to part C. Time to graph. So we're going to use our calculators to help. So take your calculator. I've got to wait before, you can't see what's on here because, oh, it's not been changed. So go to y equals. Are you in parametric mode still? Take your calculator, put it in y equals, and make sure you're still in parametric mode. Okay? So let's enter the equation up here. 3 sine t divided by 2, close parentheses. And we don't do the i's and j's, remember. 3 cosine. Oh, I forgot to write that down ahead of time. I'll go do that now. 3 cosine of t over 2. So x equals 3 sine of t over 2. Y equals 3 cosine of t over 2. So the way you graph vector valued functions is you change them to parametric and then throw them in the calculator. Okay. When you do this, especially now, Some unusual things are going to happen, so give me just a second. I'm going to make a change. Oh, okay. It's not even an issue. Push window for me, please. Now, your window probably does not look like mine because my calculator has changed since we were last doing this together. What does your T-max say?
T-max.
Does it say 6.28 blah, blah, blah? Okay, that is 2 pi, right? So I'm going to change mine to 2 pi because 2 pi is usually what sine and cosine or graph does, right? So let's do 2 pi. T-step 0.1 is fine. If you have 0.13, da 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 da, leave it there. All right, we need to set our window based on this. So go 1 out each direction from here. So I'm going to do -4, oops, -4 to 4 with a scale of 1, and then -4 to 4 with a scale of 1. If yours doesn't say that, please change it. Okay, push graph please as soon as you're done. I thought it was supposed to be a circle. What happened? It's a nice half circle, kind of a little off, not quite completely round. There is a reason that it stopped here. Does anybody know what it is?
Because the signs can't go in those other quadrants.
No, it doesn't have to do with that. Simeon, what did you say?
I said you can't have negative distance.
You can.
Negative sign.
You can have negative time, and our time was all positive anyway. There's one reason that specific to this equation. Not exactly. Look at the equation one more time. How is t affected? It's divided by 2. So if we're only going to 2 pi on our t max, it's only really going to pi. It's thinking it's only going to pi. So it's only going halfway around a circle. So go back to your window. How do I change it to make it give me the whole circle? 4 pi, exactly. So go down to here and type in 4 pi. That should give a whole circle. Try it and see. It kind of looks like an egg, I know. We're going to show you how to fix that. There is a way to fix that. Why is it kind of off? Why isn't it perfectly round? It's because the screen is rectangular. The screen is not perfectly square. Now, does anybody have a color graphing calculator in here? Is yours round? Perfectly round?
No.
The color one, yes. Do you have a question?
Mine is round.
Yours is perfectly round? Okay, those of you with the Inspired.
I hit like the zoom 4 and then it made it round.
Oh, okay. Here's one way to fix it. Your method works too. You did a zoom 4. Everybody listen, please. Please push the zoom key and go look at number 5. Number 5 says zoom square. And what that does is that squares out the screen. It makes it more proportional. So if you push zoom square, your circle should be perfect. Okay? That's a beautiful circle. Okay? Now, how far out in each direction does your circle go? 3. So let's draw this thing. Where did it start graphing? At the top. It was almost doing like a bearing thing, wasn't it? It was going in the bearing direction. Why? Why did it do that? It had nothing to do with the pi halves. That had to do with where it stopped. X is sine. X is sine. That's what messed everything up. Because the x and the sine and cosine were switched. That's why it starts at the top. Good job. Okay, so come on here, please put your 4 dots. Try to draw a circle as best you can. I don't care where you start drawing, as long as you get a circle. Ah, overshot my 3. I prefer to write in pencil, but I can't up here because it's not visible enough, so I have to write in pen. Okay. Please label where the graph started with t equals 0. And please put arrows on it to show which way it goes. Oh, look at yours. That's gorgeous.
It looks like a kite.
Okay, you guys were not here. I don't know if it was yesterday that I talked about it. If you start at the top and draw a C on either side, it tends to make it nice and round. Don't try to do it with one. Don't lift without lifting your pencil. It just doesn't work very well. Draw your arrows. That's okay. Just put your arrows on and label t equals 0 at the top.
Leave me alone, Daddy. Leave me alone.
Look at letter D. This is a very common AP question. Letter D is. Find the velocity and acceleration at t equals pi. Draw the velocity and acceleration vectors on the diagram and interpret them. Okay? So, we have our two equations already up here. So we want to know what v of pi is. The velocity at pi. So that would be 3 halves cosine pi over 2i plus negative 3 halves sine pi over 2j. Just plugged in pi for all the t's. And now you need to clean it up, because it cleans up nicely. What is the cosine of pi over 2? 0. So the first term is going to be 0i. Agreed? What about the second term?
It's 1.
Sine of pi over 2 is 1. So negative 3 halves times 1 is negative 3 halves j. So that is what v of pi is. It is a vector, 0i minus 3 halves j. Okay? Now, remember that this means you go across 0 and down 3 halves from pi. Now, I don't see a pi anywhere on that circle, do you?
Is it 3? Negative 3?
Well, where is it? Let me show you how to find it on the calculator. So take your calculator for me, please. Everybody take your calculator, and I want you to push the trace key. Push trace, and now it's asking, well, where do you want to trace to? And it's asking for the t value. So if you put in second and pi, notice at the bottom it says t equals pi, and push enter, it shows you where it is. And it's over on the right. So I'm going to darken in that dot and put that that is t equals pi, right there. So at that location, I am going to draw this vector. It goes left and right, nothing, but down 1.5. So from right here, I'm going to go down 1.5 and draw my vector, and this is v of pi. All right, now let's do the, can you do the same thing for the acceleration? Do the math for the acceleration for me right now. Do a of pi. I'll wait just a second and let you do the math. A of t is up here, remember? So figure out what the vector is going to be for a of pi. Okay, if you can do the math, you're halfway there. How is this vector going to look?
It's gonna go.
It's going to go left from that same dot. And it's going to go left how far? 0.75. It's going to go 0.75 of a unit. So I'm going to use the green one, my green pen, and from the dot I'm going to go 3/4 of a unit to the left, and this is a of pi. There's my acceleration vector at pi. Any questions about what we did? We just found the velocity vector, we found the acceleration vector, plugged in pi to both of them, which gave us the specific vectors at pi. Now I have a question for you. We're going to do the math for this too. This is kind of a side note. If I took the original equation r of pi, what would it give me? What would it give me? Well, let's do the math and see what it is on the picture.
3i plus 0j.
It would be 3i plus 0j. What significance is that right there?
Isn't that the pi?
That's where the dot is, isn't it?
Yeah.
Yes. So if you didn't have a calculator, let's say they gave you that picture on the AP test, just like that, no calculator. And they said, find these two vectors at pi. Well, if you didn't have that trace feature to go find it, this is how you find it. You plug pi into the original equation, and that's the location of the dot. Do you follow what I'm saying? So this is the location of the quote dot, end quote. That's where the vectors are going to go. You plug it into R to find out where the vectors go, and then you plug it into V to make the velocity vector, plug it into A to make the acceleration vector. Okay, it's the same kind of thing. It says sketch the path of an object moving along the plane curve, that's a plane, not place. R of t equals e to the t squared I plus ln of tj, and find the velocity and acceleration vectors at t equals 1. So it's very similar to the last one, but we're going to not get it into rectangular form. We're going to go straight to the graph and then the two vectors. So first thing I want to do is up here, I want to write down my two equations, x equals and y equals, that I'm going to put into the calculator. Okay? What is the x equation going to be? E to the t squared. E to the t squared. The y equation is going to be ln of t. All right. So, calculator. Dun, dun, dun. I found the left side of the screen actually gives me much better resolution on my calculator. So I'm going to try to keep it over here more a little bit. So e to the t squared, and then ln of t. All right, do not push graph yet. We've got to set not only our window, because notice how far does the x-axis go on this picture? It goes all the way to 20. So we're going to have to definitely adjust. We've got to think about what t can be. Okay? So, what are you allowed to plug in for t here? Anything? Could I plug any positive or negative number in here? Yes. But what about here? I can only plug in what? Numbers bigger than 0. Agreed? Okay. So when we go to window, we have to set our Tmin and Tmax accordingly. I can't have negatives this time, and it's already set that way. It's set to go start at 0. Tmax being 4 pi, well, this graph isn't in terms of pi. It's not even cosines or sines. So what do you want to try Tmax to be? Anybody got a guess? Okay, I'm going to purposely do it wrong. All right? Let me show you what happens when you do it wrong. I'm going to say the Tmax is 50. Whoops, Tmin is 0. Tmax is 50 and T-step is 1. Okay? I'm just guessing. And I'm going to show you what the graph does if you guess wrong and how to fix it. Now we need to set our window this way. I want xmin to be -1 and xmax to be 21. And the scale is every 2. The scale is important, folks, to find out where the graph's going to go. And then the y's need to go from -2 to +2, the scale of 1. Please look at my graph and watch what it's going to do. It's going to really not do very well. Watch what it does. Blup. Yuck. That's yuck. That's yucky. Okay? The problem here, it's supposed to be a nice curve, but there's no curvature at all. Most parametric equations curve. That one doesn't curve. That's kind of like a straight line. That's because my t-steps are too far apart. Okay? My t-steps are way too far apart. So go back to window. I'm going to lower this down to say, actually I'm going to lower it to 10 with a t-step of 0.1. If it doesn't graph the whole way across, just like our circle, make your t-step Tmax farther. So let's try this. Graph. Oh, that did do the whole thing. Okay? I was thinking 10 would not be enough. But that's not a bad graph. Now you see the curve, right? See how it curves nicely? Now my question is, where is it crossing? I've got to have that point pretty exact.
Maybe at like 3.
Those marks are every 2. So what does it look like it's at?
3.
About 3-ish. Okay? So when you go to graph it, put a dot around 3. That's where your crossing point is. You need to come down this way. And I never go above 1. So I'm going to make this kind of curve around and flatten out like so. Never go above 1. The question says, now we're going to find the velocity And which way did it graph? Did it graph right to left, or did it graph left to right? Do you remember? If you don't, you go, oops, I forgot. Go back to the equation, type over one thing. Just type over it with the same thing, ln, just right on top of ln. And push graph and it'll regraph it. Started at the bottom, didn't it? So that tells me I got to draw my little arrows going from the bottom up. Like that. I need to know where t equals 1 is. So what do you push on your calculator to do that again? Push the trace key. Let's move it over here. Trace. T equals 1. Oh, that's that dot right on the line. Okay. What do you recognize x to be? What number is that?
T.
That is e. It is e. Look at your x equation. Does that make sense? If t equals 1, doesn't x equal e?
Yes.
And y equals ln of 1, which is 0. Okay, so this is t equals 1. There it is. Now that we finished drawing and we found that the point is at 1, we are going to do the next step that it asks for. Find the velocity and acceleration vectors at 1. So we need to take the derivative of the r equation. So, starting with this one, what is the derivative of e to the t squared? 2t e to the t squared. Copy paste times the derivative of the exponent. Very good. I plus ln's derivative. 1 over t j. Very good. Okay. So now the acceleration will be I have to do product rule here because I have two t's. Do you see that? So 2t times d2 2t e to the t squared again plus 2 e to the t squared times 2 I. Plus, be careful.
Is it 1? No.
Okay, how can I rewrite that with a negative exponent? What would it be? Be to the negative 1 power right now. So take the derivative of that. Negative 1t to the 0 or negative 2? Negative 2. So negative 1 over t squared is my j. Okay, now they want to know v of 1, a of 1, and we need to graph them. So v of 1. So 2 times 1 is 2. 2e to the first, I, plus 1 over 1, j. So we're going to approximate this. E is 2.7, right? So 2e would be about 5.4i plus 1j. So what does that tell me? That tells me that I need to, from my dot, go 5.4 units right, 1 unit up, draw a vector. Okay? So I'm going to do pink as velocity. Now notice the spacing here. 5 units, 5.4 would be about, there's 2, 4, it's almost to the 8 actually. Because I was at 2.7, that was E. If I had 5.4, that's like 8.1. It's just barely 8. So go to 8, go up to 1, put a small dot, that's where the head of your vector is going to be. The tail is at t equals 1. This is v of 1. So from your dot, you go however far I told you, and then up 1, because it's 1j, and draw in your vector. Okay, the A1 will be 2 times 2 is 4 e to the first plus What's the second term gonna give me?
E to the first, E to,
Just 2e, right?
yeah.
I minus 1j. Agreed? So 4e plus 2e is 6e. I don't know what that is. Well, according to my calculator, it's about 16.3. So 16.3i minus 1j. So that's how far I'm going to go for the a vector. Starting at the same initial position on the x-axis, I'm going to go 16.3 to the right. Now, if this right here, I'm going to come out to the margin, that right there is about 2.7. If I'm going to add 16.3 to that, where am I going to be? 0 at 19.0. So go all the way over to 19, which is here. Oops, I want the green one. Go all the way over to 19 and down to 1. So it's right about there. I'm going to have to turn my paper to make it work. Last time I did it. Actually, no, I've got a ruler. Last time I did it, it was right ridiculously crooked. There we go. And there's my a vector. A of 1. Do the best you can. If it's not perfect, it's okay. They will not give you rulers on the AP exam, so they will also not take off for crooked lines. It says to find the speed, but we're going to stop on that. We're going to skip that part for now. But I do want to look at what happens to the position, the velocity, and acceleration as t approaches infinity. Okay, so the limit as t approaches infinity of r of t. Looking up here at this first component, if I plug infinity in for t, what will that equal? Infinity, won't it? Do you all agree that that's going to be infinity? So it's going to be infinity for the I, and what's the ln of infinity? Infinity again. So infinity for the j. So it's just basically going up and up as far as that is concerned, which you can write as infinity, comma, infinity in the component form, which is kind of strange. But basically what that's saying is you go out to infinity, it's just going to keep going up and it's going to keep going right. That's what it says. Now let's take a look at v of t. V of t is up here. This is going to be a little different. Look at what's in front of the I. 2 times infinity times e to the infinity. That's infinity. But look at the j component. What is 1 over infinity?
0.
That is 0. So that means plus 0j, which is very simply written as infinity I. Now what infinity I means is it means the vector is only going right, but it is not going up at all. So as you approach infinity, the velocity is continues to go, the velocity vector continues to go in the flat direction. Do you follow what I'm saying? It's going off to the right. And the limit as t approaches infinity of the acceleration vector so that's going to be, where to go? There we go. That's still infinity right there. All that's infinity, but the second term, right here. What is 1 over t squared going to go to? 0. 1 over infinity is 0 again, even though it's negative, still. So it's infinity for the I and 0 for the j again, which is infinity for the I. So both the velocity and acceleration are headed to positive infinity in the horizontal direction only as you continue to approach infinity for time. Any questions? Okay, let's work through number 5. Now, number 5 is similar to something we did last class, and it had to do with antiderivatives, okay? So, we're not going to do 4, so I'm going to mark 4 out, and I get all of this space down here to work, which you're going to need some more than what they give you. The particle with initial velocity I plus j and initial position 1, 1 has an acceleration vector of this. Find its position at t equals pi. Okay? So, I'm given acceleration. I need to go to position. Is that a derivative process or an antiderivative process? Antiderivative. How many times? Twice. Okay? So, because they give you an initial position and an initial velocity, you have initial conditions to find your C's. Okay? So we're going to do it one step at a time. I'm going to move over a little bit. This will be enough room. Let's recopy A of t. A of t equals negative cosine ti plus sine tj. What would the velocity be? You're going to need a parentheses, I'll tell you right now. I'm doing antiderivative.
Negative cosine.
What is antiderivative of negative cosine?
Negative sign.
Negative sine, very good. So we write negative sine of t plus c1i. Remember, you get a constant in there every time you do an indefinite integral or an antiderivative. Plus, parentheses, what's the antiderivative of sine? Negative cosine t plus c2j. Okay, there's my general solution for the velocity vector. Okay.
No precision.
In the problem, I have been given what I need to find C1 and C2. What do you think that information is?
Initial position.
Okay, it's not initial position because that's for plugging into position. They tell me initial velocity. Initial velocity is I and j. Okay? Yes, it is 1 and 1. So initial means when t equals 0. I know that the initial velocity is 1 and 1, 1i and 1j. Okay? So that tells me what's in front of I needs to be set equal to 1, and what's in front of j needs to be set equal to 1 also. So I go like this. Negative sine t plus c1 equals 1. But I made a mistake. I'm supposed to be plugging in what for t? 0. So make that into a 0. There's your first equation. And then your second equation is negative cosine 0 plus c2. And it's also supposed to equal 1 because it was 1i and 1j. Now that looks like sine of 0, sine of theta, but it's really sine of 0. What is the sine of 0? 0. So C1 equals 1, right? And what is the negative cosine of 0? Negative 1 plus C2 equals 1. So what does C2 equal? 2. Okay? So now I've got my constants taken care of. So we're going to rewrite V of t with those constants in it. So we do negative sine t plus 1i plus negative cosine t plus 2j. Just plugged in those two numbers I just found. So now we have the exact velocity vector. So what do you think I'm going to do now to find the position? Take the antiderivative again. Do exactly the same thing one more time. So r of t is the position vector. Parentheses. Antiderivative of negative sine. Positive cosine of t plus the antiderivative of 1. Not 0. T plus C1 I. plus parentheses negative sine t plus what? 2t plus c2j. Okay, now we are on the position equation. So what do they tell us about position? They say the initial position is 1, 1, okay? So what is initial meaning? T equals 0. I'm going through the point 1, 1. So that means I'm going to do exactly what I did before, because the point last time was 1, 1 also. That was a coincidence. It doesn't always work that way. So cosine 0 plus 0 plus C1 equals 1. Negative sine 0 plus 0 plus C2 equals 1 also for the 1, 1. Okay, cosine of 0 is 1. So 1 plus C1 equals 1. What does C1 equal? 0. Okay, over here, negative sine of 0 is 0, 0, 0. So I just get C2 equals 1 done. That was easy. So now we write our equation with our C's. Cosine t plus 0, oops, close parentheses because I don't need anything, I, plus negative sine t plus 2t plus 1 j. Okay. Is that what they asked for? What did they ask for? The position at pi. So what do I do with the pi? Plug it in for t. Exactly. Now that I've got the position equation, that's easy. R of pi equals cosine pi plus pi I plus negative sine pi plus 2 pi plus 1 j. At least we're talking about all these pi's after we ate, right? No, we didn't eat. I'm still hungry. Okay. How does the first parentheses clean up? It would be negative 1 plus pi, or pi minus 1, doesn't matter, I, plus, what about the second parentheses? 0. So 2 pi, oops, 2 pi plus 1 j. There we go. Now we're done. That's a lot of work. Now, if they'd asked me for the velocity at pi, I could have stopped way back up here and just plugged the pi in. So make sure you don't go all the way if you don't have to on these problems. Stop where you're asked to stop. All right. Any questions from you guys? That was long, yes. Okay, we are actually done for now.